আছে এখন?
না, অনেক সাউন্ড কিন্তু আসছে না।
এইখান থেকে সাউন্ড মোস্ট প্রবাবলি যাবে না। না,
অন্বেষা ম্যাডাম জয়েন করছেন, একটু দেখ।
হ্যাঁ, একটুখানি এসসি ম্যামকে যদি জিজ্ঞেস করা হয় কতক্ষণ নাগাদ জয়েন করতে পারবেন, সেই অনুযায়ী উই ক্যান অ্যাডজাস্ট।
লিংক পাঠিয়েছিস?
এসসি যেটা আমার আই লেখা মনে হচ্ছিল, তাই জন্য আমার অসুবিধে হচ্ছিল। ওকে, ঠিক আছে।
Madam, shall we start?
হ্যাঁ, আরম্ভ করো।
ম্যাডাম,
ওটা যেটা না আই আমি করছিলাম, তাই হচ্ছিল না। ওকে, ঠিক আছে। আমি তো শুরুটাকে লিখেছি যে হাফ অ্যান আওয়ার পরে। হ্যাঁ হ্যাঁ, বলো।
Madam, I shall start. Madam, do I start? Good evening, everyone. On behalf of the Department of Geography, East Calcutta Girls College, I welcome you all to the first of a series of special lectures being organized by our department. I hope that you all and your near and dear ones are doing well amid this unprecedented global health crisis that we are all going through. We are delighted that you have joined us despite all the challenges of contemporary life. Our esteemed speaker for the evening will shortly join us. But Today is also World Environment Day. And this year, the United Nations has announced as the theme of World Environment Day, reimagine, recreate, restore. We need to restore our world. We need to restore it back to some kind of semblance of normalcy. That's what we all are trying. But in order to celebrate this day, despite the challenges, some our college and our students have put together some presentation. So today's program will have two parts. In the first part, after the welcome speech by our principal madam, we'll have three short presentations by our students. And thereafter, as soon as our speaker joins us, we'll have the second part with her lecture. So with that, at this point, or without further ado, I would like to request our principal madam to kindly deliver the welcome speech. Madam.
Madam, you are muted.
Good evening, everybody. I first welcome all participants, especially there are many colleagues, college teachers from other colleges and students from my college and other colleges. The first part, as announced by Professor Rajarshi Dasgupta, that we will just celebrate 5th June World Environment Day. We know that UN theme, reimagine, recreate, and restore. With the growing population, we know we are daily losing our forest for urbanization. And still the rate is 4.7 million hectares per year. This is the size of Denmark. With increasing population, there is the increase of waste material. We are still using plastics. We are still just discharge different waste material into our oceans. We are getting information that under the ocean there are some islands which are mainly formed due to the depositions of the plastics. We live in the deltaic Bengal. Here there are many channels, tidal creeks, wetlands, river, but we don't know, we don't go to the side of the river. Now, sometimes we spend our days on the within our house. This is the time of pandemic. Definitely during this time we must stay within our house, but we have to do something beyond this period. And we have to think why we are facing this situation. The main theme is restoration. Restoration means mainly it means to stop the damages to the nature, damages to the resources, damages to the forest. We should stop that. We are discussing many things nowadays for awareness. There is a syllabus on environment. I know we, including me and all teachers and all students, we are reading or going through many environmental books, many environmental many papers and all that. But still we need to do some practice. Nowadays we actually in many colleges There are eco clubs. Eco clubs now we are going 2 feet back. Now we are waiting for the good days, and we want to restore, or we want to recreate good garden, at least in our locality. As our students, they started to clean the surroundings, especially in NSS group, the young group. And we live in the places where there are many canals, many short streams, and also we live in that region where a huge amount of rainfall occurs during rainy season. We need to feel that nature. We need to feel that the rainy days, and also the rains, the importance of rainwater, because even in Salt Lake, which is a satellite town of Calcutta, the drinking water is salty. It is not of good taste. Sometimes we store the rainwater, keeping a pot on the top of the roof. And if we do that, you will see what is the taste of the clean rainwater. But we don't have any good water management system, rainwater management system. It goes from the roof of the house to the drain, from drain to canals and rivers, and ultimately to the oceans. But ocean, it is the gift of ocean. It is the gift of ocean, and we get it from the cloud. But in the urban areas, there is no space to percolate within the soil. So we waste that. We are talking about sustainable development, but I think it needs more and more research for our practice. What type of practice we should do now? What kind of practice our young students will do, and they will teach us, because they are our future, and they will raise the voice. Students raise the voice for freedom, for their rights all over the world. Now this is the time to raise the voice or do a smart movement for saving ecosystem, ecology, saving endangered insects like butterflies, small birds, squirrel. They are losing their habitats. So we along with us, our students can do, after getting rid of this COVID-19 situation. In this situation, we are losing many of our friends, many of our relatives, all are our relatives. So after this period, we can start the cleaning of park. We can start the cleaning of riverside, our riverside. We can start the cleaning of wetland, because there is, and we can start the greening of our home. We can start our awareness program from our home, from our school, from our college, from the front of our house on the footpath. We can plant a tree. We do not throw, we do not litter there, we do not spit there. Or also we donate some different agencies who are doing this, who are cleaning this. And we can start our smart movement through online campaign. If we go to Darjeeling, Always we are trying to go Darjeeling, which is very near to us, or Digha. Sometimes we are seeing that spitting and waste materials are there, here and there, which causes nuisance, which causes very bad. There is no such causes of throwing these things. We usually go to enjoy the hill of the Queen of Hills, but we don't know how to save that place. So I don't say anything or many things here today. I must say that if we go to the Jungle Mahal, we give space to the tribes. We must go to the riverside but enjoy only. We must keep or maintain green space in the towns and cities, and don't we may pressure the coastal areas, because coast are now very much fragile coastal areas. I just only announce today for the students, for the students of East Calcutta Girls College, and also for the students of also for all teachers and me too, that we must plant a tree today on 5th June and send a photo with GPS location to their college, college eco club or anything, and any organization, mentioning the time and date, and we take care of that plant, watering that plant, or sometimes domestic waste. We keep a domestic waste, kitchen waste in a place and put it to that plant. After 1 month, again we send a photo with GPS location, and after 3 months we will I hope that it grows at least few inches. It grows, it responds to our love. And after 3 months, in the month of September, once we can plant one more tree. In the month of December, January, one more, and April, one more. So 4 plants, small plants, even on the roof, or in the balcony, or inside the room, or in front of the house, where it is possible. If we plant 4 trees in a year, 1,000 students make it 4,000 in a year. So after 2-3 years, from thousands, then it becomes lakhs, then it becomes millions. And anywhere, if we try to make the greening of our home, or the fronts, or the roofs, we will see that insects like butterflies and birds, they are coming. At the end, I must mention about the pioneer environmentalist Sundarlal Bahuguna. We lost him on 21st May due to COVID-19. We know about Chipko movement. We know his wife, Bimla Bahuguna. And I must say, Bimla Bahuguna started that movement. Women can start enormous work. And Bimla Bahuguna, Sundarlal Bahuguna, they are not from a big family. They are not from they don't have a strong economic background. They don't have strong power. They have only love for the nature. They have only love for the trees. They can motivate the village people to love the trees and to save the trees. And it becomes a movement throughout India, not only India, it goes to beyond India, and it becomes international. He realized the environmental crisis. He realized the risk, and he realized which vulnerable condition we will be going to if we destroy forest. So satellite actually capture images. Bahuguna's eyes capture the love of the nature and the images of each and every leaves of the tree. So we must try to do to that extent with which we can. I wish that we will start to restore, we will start to reimagine different projects, and we will start to create or recreate our new environment. Thank you. Thank you all.
Thank you, madam, for your inspiring welcome speech. We have been joined by our esteemed speaker for the evening. Welcome, madam.
Welcome. Yes, I've seen Shubhamita join just here. Yes.
Madam, should we go ahead with this in the presentation as planned now, or have?
Yes,
SC
we
madam,
have 15-20 minutes for short presentation by our students on 5th June World Environment Day. So I request Shubhamita to stay with us, our students, and they will present within few minutes. And I hope Shubhamita will enjoy with us.
Thank you, madam. So the first of our student presenters today is Miss Shreya Shaha, who is in 4th semester of her undergraduate course in geography in our college. Shreya?
Yes, sir.
Go ahead and start your presentation, please.
Sir, is it visible?
Yes, it is.
Okay. Good evening to all. এখানে উপস্থিত সকল স্যার এবং ম্যামদেরকে প্রণাম জানিয়ে আজকে আমি আমার বক্তব্য শুরু করছি। ধনধান্য পুষ্পে ভরা আমাদের এই বসুন্ধরা, আমাদের এই পৃথিবী সত্যি এক বিস্ময়কর সৃষ্টি। ক্ষুদ্রাতি ক্ষুদ্র কীটপতঙ্গ থেকে শুরু করে বৃহৎ মাতঙ্গ বা ঘাস থেকে শুরু করে বড় বড় বৃক্ষ, সকলেই আমরা ঠিক যেন একই পরিবারের সদস্য, যারা পরিবেশ নামক একটি বাড়িতে বসবাস করি। একটি পরিবারের আনন্দ যেমন নির্ভর করে পরিবারের সদস্যদের ভালো থাকার উপর, ঠিক তেমনি পরিবেশেরও ভালো থাকা নির্ভর করে পরিবেশের প্রত্যেকটি উপাদানের উপর। আর এই পরিবারের অংশ হিসেবে আমাদের দায়িত্ব যাতে আমরা আমাদের এই বাড়িটিকে ভালো রাখি। আমরা আমাদের এই দায়িত্বটিকে যাতে ভুলে না যাই, সেই কারণেই বিভিন্ন সময় বিভিন্ন পদক্ষেপ গৃহীত হয়েছিল। বিশ্ব পরিবেশ দিবস সেগুলির মধ্যেই অন্যতম, যা প্রতি বছর 5ই জুন পালন করা হয়। এবছরে বিশ্ব পরিবেশ দিবসের থিম হলো রিইম্যাজিন, রিক্রিয়েট, রিস্টোর। অর্থাৎ বলা হয়েছে যে কিভাবে আমরা নিজেদের চিন্তাধারা বা দৃষ্টিভঙ্গিকে পরিবর্তন করে নতুনভাবে পরিবেশকে উদ্ধার করতে পারি। পরিবেশ তো আমাদের অনেক কিছুই দিয়েছে, তবে কখনো সেগুলির দাম চাইনি। কিন্তু আমরা তার বদলে পরিবেশকে কি বা দিতে পেরেছি, বা পরিবেশের এই সমস্ত অবদানের প্রতি আমরা কতটাই বা কৃতজ্ঞ, সেই প্রশ্নটা থেকেই যায়। হয়তো আমরা এগুলির দাম কোনোদিন দিতেও পারবো না, তবে পরিবেশের উপাদানগুলিকে বা পরিবেশকে তো রক্ষা করাই যায়। এছাড়াও এতদিন ধরে মনুষ্য সৃষ্ট বিভিন্ন ক্রিয়াকলাপে পরিবেশের যে ক্ষতি হয়েছে বা যে সমস্ত সমস্যা দেখা দিচ্ছে, সেগুলি সম্পর্কে আমাদের সকলেরই সচেতন থাকা উচিত ও অন্যদেরকেও সচেতন করা উচিত। বিগত কয়েক দশক ধরে পরিবেশের উপাদানের মান অবনমনের জন্য বিভিন্ন সমস্যাগুলি প্রকট হয়ে উঠছে। ফলস্বরূপ বিজ্ঞানী মহলে এই সমস্যাগুলির সমাধানের জন্য নানা চিন্তা ভাবনা ও পদক্ষেপ গৃহীত হয়েছে। সেগুলির মধ্যেই অন্যতম হলো মন্ট্রিল প্রটোকল, 1992 সালের বসুন্ধরা সম্মেলন ও কিয়োটো প্রটোকল। 15 থেকে 30 কিলোমিটার উচ্চতায় ওজোন গ্যাসের সব থেকে বেশি ঘনত্বযুক্ত পুরু স্তরকে বলে ওজোন স্তর। এই ওজোন স্তরই পৃথিবীকে ছাতার মতো সূর্যের ক্ষতিকর অতিবেগুনি রশ্মির হাত থেকে রক্ষা করে। তবে বর্তমানে মাত্রাতিরিক্ত বায়ু দূষণের ফলে বায়ুর কিছু পদার্থের কারণেই ওজোন স্তর ক্রমশ পাতলা হয়ে যাচ্ছে। বিজ্ঞানী ফারম্যান বলেছিলেন যে ওজোন গ্যাসের ঘনত্ব যদি 200 ডপসনের কম হয় তো সেক্ষেত্রে ওজোন গহ্বর সৃষ্টি হয়েছে ধরে নেওয়া হয়। ফলস্বরূপ অতিবেগুনি রশ্মি পৃথিবীতে আসার আশঙ্কাও সৃষ্টি হয়। তাই জন্যই ওজোন স্তর ক্ষয় নিয়ন্ত্রণ করার উদ্দেশ্যে 1987 সালের 16 সেপ্টেম্বর কানাডার মন্ট্রিল শহরে মন্ট্রিল চুক্তি স্বাক্ষরিত হয় এবং ওজোন স্তরের গুরুত্বকে তুলে ধরার জন্য প্রতি বছর 16 সেপ্টেম্বর বিশ্ব ওজোন দিবস পালন করা হয়ে থাকে। এছাড়াও অন্যান্য পরিবেশের সাথে জড়িয়ে থাকা সমস্যাগুলি সমাধান করার উদ্দেশ্যে 178টি দেশ 1992 সালে 3রা থেকে 14 জুন ব্রাজিলের রিও ডি জেনিরোতে জাতিপুঞ্জের এক সম্মেলনে মিলিত হয়, যা বসুন্ধরা সম্মেলন বা রিও সম্মেলন নামে পরিচিত। ফ্রিয়ন গ্যাস উৎপাদন ও ব্যবহার কমানো, এজেন্ডা 21 ইত্যাদি বিভিন্ন কর্মসূচি গৃহীত হয় এখানে। গ্রিনহাউস গ্যাসের প্রভাবে পৃথিবীর গড় মাত্রা বৃদ্ধির ঘটনাকে বলা হয়ে থাকে গ্লোবাল ওয়ার্মিং, যার ফলাফলগুলির সাথে প্রায় আমরা সকলেই কম বেশি পরিচিত। সমস্যা সমাধানের উদ্দেশ্যেই 1997 সালে জাপানের কিয়োটো শহরে কিয়োটো প্রোটোকল নামক একটি চুক্তি স্বাক্ষরিত হয়। আমরা তো নিজেদেরকে বুদ্ধিমান বলেই দাবি করি, তাই পরিবেশের বিভিন্ন সমস্যাগুলি কিভাবে সমাধান করা যায় সেগুলি আমাদেরকেই ভাবতে হবে। এই প্রসঙ্গে আমরা উদাহরণস্বরূপ ডিসপোজেবল মাস্ক নিয়ে যে সমস্যা তৈরি হচ্ছে সেটিকে উল্লেখ করতেই পারি। করোনা ভাইরাসের হাত থেকে বাঁচতে এই মাস্কগুলি ব্যবহার করা হয় ও তারপর যত্রতত্র তা ফেলে দেওয়া হয়, ফলে বর্জ্য পদার্থ সংক্রান্ত সমস্যাগুলি আরো প্রকট হয়ে উঠছে। কিন্তু ডক্টর ভিনিস দেসাই এই মাস্কগুলিকে ইটে পরিণত করেছেন, আর এই ইটগুলি সাধারণ ইটের তুলনায় অত্যন্ত শক্ত, অথচ এগুলির দামও অত্যন্ত কম। তিনি আবারও প্রমাণ করে দিয়েছেন যে বুদ্ধি থাকলে উপায় হয় এবং কিভাবে নতুন করে চিন্তা ভাবনার মাধ্যমে পৃথিবী একটি নতুন জগতে পরিণত করা যায়। পরিবেশকে রক্ষা করার জন্য বিভিন্ন পথ আছে, তবে আমাদের ছোট ছোট পদক্ষেপ দিয়ে এটি শুরু করা উচিত। গাছ লাগানো হচ্ছে সেই সমস্ত পদক্ষেপগুলির মধ্যে অন্যতম, কারণ আমাদের মনে রাখতে হবে যে একটি গাছ একটি প্রাণ, আর এই একটি প্রাণের সাথে জড়িয়ে আছে অনেক সমস্যার সমাধান। কদিন আগেই চিপকো আন্দোলনের নেতা সুন্দরলাল বহুগুণা মহাশয় মারা গেছেন, তো তার চিন্তাধারা বা মতাদর্শের প্রতি সম্মান প্রদর্শন করা আমাদের কর্তব্য। নমস্কার, ধন্যবাদ।
Thank you, Shreya, for that nice presentation. Our next student speaker is Miss Disha Roy, who is in undergraduate 6th semester of Zoology Honors. Disha?
Yes, sir.
Please start your presentation. Or
Sir, is it visible?
not yet. Yeah, it is now coming.
Okay, sir.
It's all good now. Yeah, go ahead.
Sir. Thank you, sir. A very good evening to one and all present here. Myself, Disha Roy, from Department of Zoology of East Calcutta Girls College, a student of 6th semester. We know COVID-19 disease passed from animals to humans, called zoonotic diseases, are on the rise as the world continues to see unprecedented destruction of wild habitats by human activity. Nature is sending us a message with the coronavirus pandemic and the ongoing climate crisis. A new study by the School of Earth, Energy and Environmental Sciences at Stanford University has suggested that deforestation could lead to a rise in the occurrence of diseases like COVID-19. Its findings suggest that when forests are cleared for agricultural use, the chances for transmission of zoonotic or animal-to-human diseases increase. The SARS-CoV-2 virus, the cause of COVID-19, is thought to have originated from animals. When people venture into forested areas for resources and when animals venture out of their habitats to raid crops, the chances increase for transmission of zoonotic or animal to human disease. A prime example is HIV, which is caused by a virus that jumped from wild primates to humans via infected bodily fluids. Losing forest boundaries. New study to integrate landscape level ecological factors with individual level behavioral factors and weigh risks to human health suggests that land conservation and the reduction of forest fragmentation is our best bet to reduce human wild animal interactions. World Environment Day is observed on June 5th every year. The purpose of World Environment Day is to spread awareness about the threat to the environment due to rising pollution levels and climate change. This year, the theme of World Environment Day is Reimagine, Recreate, Restore, or ecosystem restoration. This year will also mark the formal launch of the UN Decade on Ecosystem Restoration 2021 to 2030. Pakistan will act as the global host of the day in 2021 in collaboration with the UN Environment Programme. I would like to dedicate a tribute to an Indian environmentalist and freedom fighter, Sundarlal Bahuguna, and his wife, Vimla Bahuguna, who taught India to embrace trees through Chipko movement at Garhwal Himalayas. The idea of the Chipko movement was entirely Vimla Bahuguna's, who seemed to have inspired Sundarlal Bahuguna. In 1974, local women showed enormous bravery in protecting trees from the acts of contractors by hugging them. Sundarlal Bahuguna suffered due to COVID-19 and took his last breath on 21st May 2021 at AIIMS Rishikesh. People all over the world have acclaimed the Chipko movement. Other notable mentions can be made of Chandi Prasad Bhatta, an Indian Gandhian environmentalist and social activist who founded Dasholi Gram Swarajya Sangha in Gopeshwar in 1964, which later became a mother organization to the Chipko movement. Amrita Devi, a renowned personality of the Vishnoi movement who sacrificed her life along with her 3 daughters and 363 trusted members in order to save khejri trees from being cut down by the king's soldiers for a new palace in Jodhpur, Rajasthan. The Silent Valley movement started in 1973, which aimed at the protection of Silent Valley Reserve Forest located in Kerala from being flooded by a hydroelectric project. Our students of East Calcutta Girls College are highly inspired by such amazing environmentalists and their work. Tree plantations in our college campus. US Department of Agriculture, 1 acre of forest absorbs 6 tons of carbon dioxide and puts out 4 tons of oxygen, which is enough to meet the annual needs of 18 people. During super cyclonic storms, Yas, Aila, and Amphan, we again realized the importance of trees, particularly the immense role played by the mangrove plantations in Sundarban area. These trees actually saved the entire area from massive devastation from the super cyclonic storms. Trees also lower the air temperature and reduce the heat intensity of greenhouse effect by maintaining low levels of carbon dioxide. Amazon rainforest has been considered as the lungs of the world, now become severely affected by soya plantations. Our college, with the leadership of our Eco Club, regularly plant trees. In this pandemic situation, tree plantation was done by the students of our college, particularly by the students of Department of Zoology, Botany, and some other departments in their own premises. We make this work public and circulate it among the students of other departments. We think this will also encourage other students. Our endeavor also reach to other institutions. We think they also initiate such type of activity to keep our surroundings clean, green, and beautiful. It will promote awareness among students to take care of their native environment, promote social responsibility to make their surroundings eco-friendly, provide leadership quality, and they have learned the role of a true citizen. Mushroom cultivation. Mushroom cultivation has introduced nutritional and medicinal value by providing a good environment in our college. Vermicomposting. Vermicomposting in our college has increased moisture and nutrient retention of the soil, thus providing aeration and a higher yield of quality plants. Use of solar panels in our college. Installation of solar panels in our college building helped in combating greenhouse gases emission and global warming in order to promote the use of renewable solar energy, thereby reducing the dependence on outsourced fossil fuels. Rainwater harvesting. Our college has also made the use of rooftop rainwater harvesting, which has considerably reduced demand on existing water supply and also has decreased runoff erosion contamination of surface water. Therefore, it served as a small step to save water, one of the most important elements of our survival in the long run. Bird and squirrel feeding. As our college is surrounded by various types of flower and fruit bearing trees, we chose those trees on which we hung few plastic buckets to provide food, chana, and water for squirrels and birds. In this way, little efforts of individual students did a big contribution in maintaining sustainable existence of human and wildlife on Earth. I would like to raise a deep concern about a very serious threat to our environment due to massive increase in livestock production. Animal husbandry has a significant impact on the world environment. It is responsible for somewhere between 20 and 33% of the fresh water usage in the world, and the production of feed for them occupy about a third of the Earth's ice-free land. Livestock production is a contributing factor in species extinction, desertification, and habitat destruction. Animal agriculture contributes to species extinction in various ways. Habitat is destroyed by clearing forests and converting land to grow feed crops and for animal grazing, while predators and herbivores are frequently targeted and hunted because of a perceived threat to livestock profits. For example, animal husbandry is responsible for up to 91% of the deforestation in the Amazon region. In addition, livestock produce greenhouse gases. Cows produce some 570 million cubic meters of methane every day. That accounts for from 35 to 40% of the overall methane emissions of the planet. Livestock is responsible for 65% of all human related emissions of the powerful and long lived greenhouse gas nitrous oxide. We must seriously think about it. Now, I would like to conclude with the note: let's save our environment to let save the survival of us. Thank you.
Thank you, Disha, for that nice presentation.
Thank
Our
you.
third and final student speaker for the evening is Ms. Shukonna Basu, who is a fourth semester postgraduate student in geography in our college. Shukonna?
Thank you, sir. Good evening and a cordial welcome to everyone in this webinar to celebrate World Environment Day. Certainly, considering this theme, I can think of only two numbers. One is 51 billion and other is 0. Why? Because environmental change is to be determined by these two values. 51 billion tons of greenhouse gases are added by the world typically to the environment every year, and it's increasing every year. And 0 is the target to reimagine to stop the global warming and to avoid the dreadful effects of climate change. And in future, these effects will be very bad. Now, to make mincemeat of the fact, we humans have become supreme being in regards to other animals. All in all, the world has become the kaleidoscope of anthropogenic impacts on environment that eventually turned into somewhat local bullying. Officially, we are living in Holocene epoch, but globally for the last 70,000 years, it has been Anthropocene epoch, the epoch of humanity. Now, considering the overall scenario, modernly speaking, I have come up with two terminologies as subdivisions to Anthropocene epoch. One is religiocenary level, platform including sinful activities followed in the name of religion, dominated by humans.
Shukanna,
Yes,
I'll
sir.
just interrupt you for a minute.
Yes, sir.
Can you please have your camera on?
Sir, actually, I have a technical defect, so it will be a problem to our audio.
Okay, go ahead.
Okay, sir. So I was under the Anthropocene epoch. One is religiocenary level, platform including sinful activities followed in the name of religion, dominated by humans leading to anthropogenic aftermath disasters. And the other one is politicocenary level, platform including white lie statements promised in the name of development and sustainability, highly dominated by politically powered humans. Now, religion and politics have become the two staples for us. With these two, we humans have rewritten the rules of the game. Two platforms subjugated by humans and have managed within these past years to change the ecosystem in unprecedented ways. Globally, religion and politics are seen as two different tenets, but the lines shared are glad to blend these two and turning it into a cereal bowl of human-impacted environmental risks and disasters. Next, coming to a very trendy topic, and we would surely acknowledge it, and that topic is young generation. And most of us belonging to this category are very politically inclinated, and I'm absolutely not discouraging it. But the problem lies when they're ambitious about becoming the Anil Kapoor of the movie Nayak, of becoming one day chief minister and bring the change. But nobody is ready to recreate the idea of becoming only for one day Dhrubajyoti Ghosh or one day Sundarlal Bahuguna. It's very depressing to see more political route march and less environmental movements from the educational institutions because it's not the fashion. Now the question is, what should be done about this? The idea of changing environment must not only be confined to eco clubs, not to schools and colleges, but also on fields that is a march, slogans, protests, whether be in troops or solo, and most importantly, an environmentalist fervently. But globally, we can think of spending the next decade focusing on policies, technologies, and market structures that will put us on the right track, hopefully by 2050. This pandemic has wrecked the global economy. Support for action on environment change is just high as it was in 2019. It's hard to think for a better response to a miserable 2020 that spending the next decade dedicating ourselves to restore the ambitious goal and also try not to let the near to real two levels of Anthropocene epoch to win over our goals. Thank you.
Thank you, Shukanna, for that talk of yours. Thank you to the other two student speakers as well. So without further ado, we'll go on to the main lecture part of this evening's program. We are very honored to have amongst us today Professor Shubhamita Chaudhuri. Professor Chaudhuri is the HOD of the Department of Geography at West Bengal State University in Bangladesh. She completed her PhD in coastal geomorphology at Pune University and has since then researched on various aspects of the coastal environment, including tidal inlet hydraulics, mudflat sedimentology and ecology, environmental management of wetlands and other coastal environments, as well as the hydrogeomorphology of non-perennial streams in the Himalayan foothills. Ma'am, we welcome you, and the title of her talk today is mapping and monitoring the coastal environments, guidelines, and recent trends. With that, madam, the floor is yours.
Okay, thank you, Rajarshi, and
To the student speakers, Shreya, Disha, and Shukanna, you all spoke very well, and I'm really thankful to Shukanna for mentioning the role of the youth in preserving the environment. You also mentioned Dr. Dhrupajyoti Ghosh's name. It's true that persons like Dr. Ghosh or Dr. Sundarlal Bahuguna, we also lost Anupam Mishra in 2017. So they were the ones who actually taught us to think in a different way. And what I feel is that though we try to motivate our students, we carry out small activities within our capacity, but somehow when it comes to actually practicing it in our daily lives, then somewhere we fall short of it. We all understand how we are damaging the environment in various ways. Just now somebody talked about the disposal of the masks, etc. So how we deal with our waste. These are very sensitive issues. And we must ask ourselves that what we are doing at our home, are we conscious about how we are dealing with our domestic waste? So I think when the students are educating themselves, they should also try to spread this awareness among their family members and practice what is being taught in the colleges or schools or universities. So, having said that, I go to my topic today. It is not directly related to today's Environment Day, because as I understand that it's a part of a lecture series which is starting from today and it will go on for the next few days. So I have chosen as my area of expertise, as Rajoshi pointed out, that it's the coastal area. So I chose to talk about the coastal area. I would go into my presentation.
Yes, madam?
Yes, is it visible?
Yes, ma'am, it is.
Okay, thank you. So I'm going into my presentation, but this I don't want to be, do a monologue. So anybody who wants to come up with any question, any query, can do it. So it's true that this topic, mapping and monitoring of the coastal environment, is more of relevance maybe to the postgraduate and the research scholars. So what I would like to stress on and why I chose this topic is that the coastal environment is one of the most dynamic environments because a number of processes are working in the coastal area. The rivers which are draining into the coast, the waves, the tide, the current, the wind. So many processes are coming together to shape the landscape of these areas. So it is very dynamic, and it is at the same time very challenging to do any kind of research in such a dynamic environment. Now, we come across various publications which are, using infrastructure of their universities, of the research institutes, which include using very sophisticated instruments in mapping or monitoring these complex environmental parameters. But many of our scholars in our Indian universities, we lack some of our basic infrastructure in laboratories. And we often think that how can we do the work? How can we actually monitor things in the field? So when we are going into research in physical geography, we see that increasingly we are going into a multidisciplinary approach. And it is always encouraged that the topic, if it is of multidisciplinary, then a special credit goes to the researcher. And geomorphology, in fact, inherently have the quality of being a multidisciplinary subject. Time to time, we need help from various faculties of geology, chemistry, botany, zoology, and many more. So it has this necessity for going into an interdisciplinary approach. And it is also known that we are going on using more and more remote sensing and GIS technologies. Many sophisticated softwares are coming into the research scenario. So it has become a trend nowadays to use the remote sensing and GIS techniques to deal with any problem of geography, whether it is of a social or physical aspect. But one thing which is extremely important nowadays is quantification. When we are studying a geomorphic phenomena, we are often asked about the rate of change, about the velocity of the river, or the energy of the wave. So somewhere we have to quantify some very difficult parameters which are otherwise can be monitored by sophisticated instruments in the field. But we have to incorporate some alternate methods to come up with quantification by using some other methodology if we do not have such instruments at our disposal. Using an instrument itself is not very easy. We have to understand the working principle of the instrument. We must also see that the results that we get from the field, they can be checked for their validity and reliability. And the results should not be unbiased, should be unbiased. So, what is very important in case of research in physical geography is fieldwork. More and more, we are going towards a research trend where we are increasingly depending on our remote sensing database, our secondary data sources. We often forget that remote sensing is a tool which has to be validated by ground truth verification. So I feel that in today's research in physical geography, field work is absolutely indispensable. We cannot do a proper research in physical geography unless we go to the field, because it is a field-based science. It is true that in the past 1.5 years now, due to the pandemic, we have not been able to go to the field. Our dissertations are now being totally dependent on secondary database, but this is a passing phase, and this should not be the trend. Now, when we go to the field, many of you may have gone in your undergraduate classes or in your previous experiences sometimes with your teachers. And what I have found is that we are more comfortable in mapping and monitoring the changing forms, changing geomorphic features, rather than monitoring the processes which are actually working there. For example, it is relatively easy to do a beach profiling or do a geomorphic mapping of a beach area, or take a cross-section of a river, or map the bed forms which have formed in the river valley. But it is very difficult to measure the processes like wave, tide, current. These are the challenges that we face when we go to the field. So, what I am trying to show you with 2 case studies, one from the Western Coast, where I worked for my doctoral research, and another from the East Coast, very well known to us, that is Digha. So, first, I'm going to the West Coast to tell you something about how we can do a process study, process monitoring. So this is just, I'm introducing this area so that you can understand that how we are working and what type of findings we are coming up with, what techniques we are using. So this is an area which is a small bay. you know what is headland and what is a bay, and this is a bay mouth spit. Now, when I first visited this area, I was given a very difficult question to answer, and my supervisor told me, can you take up this topic of this bay and tell me whether this bay will get filled up and reclaimed in the future like many other bays in this part of the Konkan coast. So when I saw this bay from this headland, the southern headland, I was standing here and looking at this bay in front of me, and I found that this spit has, increased in length towards the south, and a very small portion is remained open. So I first of all thought that it won't take long before this spit will grow and it will close the mouth of the bay, and then the bay will be reclaimed. So I started to work with this hypothesis in my mind. And so there were a number of questions which had to be answered. Many questions come when we are working in a field. So I had in mind, okay, the spit is growing, but the material which is being deposited at this end, will it remain there? What will happen if there is a very high energy wave condition and the material is washed away? Is there any seasonal change in the wave character? What is the trend of erosion and deposition along this coast? What type of material is coming in? The material which is going into the bay, is it coming from the sea or is it coming from the land? So various types of questions cropped up. So let me tell you how I started to take up one after another. With very limited resource in my hand, we started work. So just a glance at the bay in 1988. These are, as you can understand, these are standard false color composites. 1997. Yes?
শুভমিতা স্লাইডটা মুভ করছে না।
Oh, is it? Sorry?
Okay, it's okay.
No, I think, shall I go to present my whole screen?
Yes,
Yes, it will be okay if you make it whole screen.
Okay, I'm stop presenting and going again.
This slide show full screen.
Okay, is it visible?
Yes, madam.
Yes.
Okay. So just a glance at some of the temporal images. These are some false color composites, standard false color composites. 1988, 97, 2008, and this is 2017. So you can see just a cursory glance that the area within this bay is changing a lot. There is still some water. So the bay has not been reclaimed yet, but yes, there has been changes. And I wanted to see how we can monitor these changes. So first, the morphological part of the mapping. Has the slide changed?
Yes.
Yes, madam.
Okay. So in case of the morphological mapping, This is a very common way of working, that is change detection. All of you must be knowing about this very basic application of GIS, when we generate some vectors and we superimpose them on one another to see the changes. So this is a very common method. What is important in this case is, in case of coastal areas, matching the vectors should be done with caution. Why I say so? Now, what is written here, that here the low tide lines have been superimposed. So you know that the tide is changing, the tidal level is changing every day. So when we are trying to map the low tide line, then we must choose a time of survey when we have the lowest low tide condition, that is during the spring tidal condition, যেটাকে আমরা পূর্ণিমা অমাবস্যা বলি. So if we choose that time, then it is better, because we can have the maximum exposure of the area and we can actually see the low tide line, and we can map it by either total station or any other survey techniques. So here two vectors have been generated from topographical sheets. So that is not a problem, because it's already drawn on the topographical sheet, so you can just digitize it. But when you are surveying, then you have to really be very cautious about the time of survey. Otherwise, you cannot match the vector. You can match, but that will not give you a proper conclusion. The same thing applies when you are going for a satellite image. So here I am giving that example. Here the high tide lines have been superimposed. So some of the vectors have been generated from topographical sheets, some vector from sounding charts, some from GPS survey. Now, here I come to another critical part, that is matching the GPS vector with the topographical sheet vectors. That is again a very, very important thing which we must understand, otherwise we will go wrong. Now, when we are choosing a satellite image also, and we are trying to digitize the high tide line from that image, we must be careful about the location of the high tide line. We must see for the difference in the color of the sand and try to find out the boundary between wet sand and dry sand, and then we will draw the vector. Now we are very, very comfortable in using the GPS, handheld GPS or the DGPS. We just put it on and then we walk along the area and that vector is generated. So it is a remarkable instrument, very useful, very handy. Everything is true. But when you are matching a GPS vector with a Survey of India vector, then we must keep some things in mind, and that is the two coordinate systems followed by the GPS and the Survey of India maps are different. I'm talking about the old Survey of India maps, which were drawn, the coordinates were drawn from a reference ellipsoid, which is the Everest ellipsoid, and the GPS, which works in majority of our instruments, is taking the coordinate system from another ellipsoid, and that is the WGS 84. So this is very important, that when we are trying to match these two, what should be kept in mind? So let me first show you this diagram. So the largest circle that is drawn here, this is the geoid, or the typical shape of the Earth. That is not a regular outline, but it has ups and downs. Now, averaging out the high and the low areas, we can draw a best fitting curve, and that is the WGS 84 ellipsoid. Now, the GPS takes the X, Y, and Z, that is the XY are the positional coordinates, the longitudes, latitudes, and Z is the altitude. So it takes the XYZ from the center of this ellipsoid, which is the WGS 84. So here, the CW, that is the center from where we are considering the X, the Y, and the Z. Now, for the Everest, since we want to represent the north and the eastern part of the Earth more accurately, so here the Everest ellipsoid is not having the same center as the WGS 84. So that ellipsoid is a bit towards the right, shifted towards the right, and its center, CE, it is somewhere here. So when we are trying to find the X and Y and Z from the Everest ellipsoid, they are somewhat different from that of the WGS 84. And here I've given a table where you can see that how much the axis is different from the Everest and the WGS 84. So if we just superimposed two vectors, not doing any correction, then it will show a major shift in the two vectors generated from the topo sheet and the GPS. And we may jump into a conclusion saying that a huge change has occurred in this area, which may not be so. So that is why we have to first collect some ground control points or GCPs from some areas which are not changing, like some anthropogenic features, like say road crossings of road culverts and bridges, things like that, which are present in the topographical sheet and which are also identified now in field. So they are some permanent features. So we have to take the ground control point of those areas by the GPS from the WGS 84 ellipsoid. And when we are digital georeferencing the topographical sheet, we find out those same points, the coordinates of those points. And then we match and see that how much is the deviation between this and the GPS reading. Likewise, we have to distribute this error and rectify the two. Otherwise, when we superimpose them, we may, land up into wrong conclusions. Now coming to how we can monitor coastal processes. So, process study, as I told you, is, it is very important, and recent trend of geomorphic research is actually going towards the process study. But it is very difficult to do a process study. It is difficult because we have to monitor how the waves are coming, what is the energy of the waves, and these are, we cannot do with our conventional survey instruments, etc. So we have to see that how we can, we can replace some of the instruments by using some empirical formulas or methods. Of course, for that, we need some data which we have to incorporate in our study. So, process study in a coastal area, as I told you, that it is very complex because a number of processes are working together. And there are various engineering structures which have been built on the coastal areas, which are modifying the processes. And this I will illustrate with my example of Digha, you will see. And these processes have a very high degree of variability, both spatially and temporally. So let's see how we can do our process study. These are some very conventional instruments that we use to monitor the waves. But again, these are not easily available to many of our universities unless they are specializing in coastal research. So these are some instruments. Of course, visual observation is there. And what we actually measure in case of waves is only two parameters. What is the wave height and what is the wave period? These two are the only two parameters which we can actually measure. The other things we have to quantify by using some equations. So visual observation is very tedious method. You have to keep on looking at the staff, and you have to see the stopwatch, and then you can take the wave period and the wave height. But it is not at all an easy task. You have to use a very powerful telescope because you have to see the wave beyond the breaker zone. So the breaker zone is quite some distance from the coast. So measuring something visually at such a distance is not easy. This is also a simple instrument, but it is used to measure the swash and backwash pressure. So it has a spring. So when you place it in a way that the swash is coming and it presses the spring, and you can see the power of the swash. Likewise, you can also see the power of the backwash. But again, using these instruments on the field is not easy. Setting up this instrument and to make it sure that it is not washed away, that is again a big challenge. You can use some photographic techniques. You can apply some dye, non-soluble dye color, that is color on the water, and then you can monitor by video recording or some other measures by taking time-lapse photographs and see how water is moving, in which direction, how the current is going. So those can be done, but again, it is not easy for a large area. You can do it in small areas. We have done in small tidal creeks, monitoring the flow by putting some potassium permanganate in the water, which is harmless. But it is very much scale dependent. That is, you can only do it in a small area, manageable, but not in a large part of the coast. So in many cases, for quantifying the wave parameters, we have to depend on some secondary data and do some calculations based on some of our field generated data, and together with that, some equations. So this is a data which is of wave climate. Now you all know about climatic charts. You have interpreted weather maps, but wave climates are a bit different. As I told you that only two parameters, the wave height and wave period, are shown in this diagram. The sole authority which used to publish this data was previously National Institute of Oceanography in Goa. They used to publish these data. But now some other agencies are also coming up. So see this diagram. It has all the degrees shown here. So these lines, it actually shows us the direction of the wave approach. Now, what are these concentric rings? They are signifying percentage of time. Each ring signifies 5% of time. So 5, 10, 15, 20, like that, you can go up to measuring the total percentage shown here. And these are shown for each month. So, say this direction, I can see that it is covering 5, 10, 15, 20, 25, 30, 35, 40, 45%, even more. So 50% of the time, that means that in a month, more than 15 days, I'm having wave from this direction. So I can find out the dominant wave direction. Likewise, I can also find out what is the dominant wave height and what is the dominant wave period. These are written on two sides of the line. On one side, 8, 6, 7, 10, these are the wave period in seconds. And on the other side, 3.5, 2.5, these are the wave height in meter. So you can just see that there are markings and the dominant wave height and wave period you can find out from this data. Now with this data, you can do some simple calculations. We can determine the level of turbulence that is affecting the coast. We can also determine what is the swash and backwash velocity, what is the energy of the wave in the breaker zone. So all these quantifications, and also we can determine the breaker type. So these can be done by applying some of the conventional equations which are time tested, which are well established by various authors like Airy or Stokes. But here also we need some field data, and that is we have to find out the slope of the beach. In order to find out the breaker type, we must know the slope of the beach. So see, the M parameter, that is the beach slope, and that is generated from field data. So you do survey in the field, you find out the gradient of the beach, and then you apply these wave parameters in the equation and you find out the breaker type. I'm not going into the details, and this is just to give you an idea that how you can incorporate your field data into some equations, and you can find out some things which are otherwise very difficult to find with instruments. You can also find out the breaking wave type and the energy of the breaking wave, because that is what actually determines that how much erosion the beach will suffer. So incorporating all the equations, this red line is actually, the calculation of all what I have shown before, and it is showing that at 3 meter depth, the wave is breaking and the energy of the breaking wave is 8.194 joules per meter, of course, to the power 10 to the power 5. All data is 10 to the power 5. So 8.194 joules per meter, that is the energy of the breaking wave. So I find out the depth at which the breaker zone will occur, and I also find out the energy by which the wave is breaking. So I can do a very simple map by the 3 meter depth I have already found out. So this is the breaker zone I have marked on the map. This map is not a normal map, it is a bathymetric map. What is a bathymetric map? It shows the depth values of the bottom of the ocean. So if I can just measure the width of the breaker zone, and I can also put that in the profile, the beach profiles that I have drawn, and I can continue the profiles with the sounding values that is shown in the map. So part of these profiles, the upper part is from survey, and the lower part, which is below the water, that is from the sounding chart. So here again, I'm merging two data. One is my survey data and another is a bathymetric chart data. So here also a word of caution. See, when we are doing any survey in the field, then we have to take some datum value. from which we determine the heights. It can be any instrument, but we have to have a datum value. So when we are trying to match the surveyed profile with the map profile, then we have to just make it sure that both the map and the survey is using the same benchmark or the same datum height. And then you can adjust your survey data and then you can merge it with the sounding data. Another very important thing which is required to be quantified, not quantified, rather shown, that is the direction of the wave approach. How the waves are coming on to the coast, and that is called wave refraction. So this actually tells us which part of the coast is prone to erosion and which part of the coast is prone to deposition. So this is a method which is given by the US Army Corporation of Engineers. This is a template which is used to draw the refraction diagram, and this is the result. So here two waves have been superimposed with two dominant directions, and here you can see that some areas the waves are converging and in some areas the waves are diverging. So where the waves are converging, those areas are prone to erosion. Where they are diverging, those areas are prone to deposition. The wave refraction also can tell us about the probable direction of the longshore drift, because that is also a major process in the coastal area. So here is a small inset in this diagram, and the angle of wave approach can tell you that in which direction the longshore drift will go. So if it is coming from this direction, the longshore drift in all probabilities will move in this direction. When it is coming from the other side, the drift will also change its direction. And so with the change in the direction of wave approach seasonally, the longshore drift also changes, because as you know that the coast is actually affected by wind waves. So when the winds are changing direction, the waves are also changing in the direction. And so seasonally we see there is a reversal of longshore drift along the coast. The next very important process is the tide. Now, in case of the tide, there are some available tidal charts which look something like this. But as you can see that here, you can only have 4 values. Since we have semi-diurnal tide, so we have 2 highs and 2 lows in a day. So for each date in a month, you will have only 4 readings: the high, low, high, low. So that is all we have for the entire month. Now, when you need to have a detailed tidal record, that is how much time it is taking for the tide to rise and how much time it is taking for the tide to fall. So the flood velocity and the ebb velocity. Then sometimes we need to do tide monitoring in the field by a simple staff that we use for our leveling survey. That staff can be used as well. I'm not going into that procedure now, but actually what we do to monitor tides we try to find out the tidal period, that is the difference in time between the high tide and the low tide, and the tidal prism. Now, what is the tidal prism? It is the volume of water that is entering during high tide, the total volume of water entering into a inlet or a bay in the high tide, that's called the tidal prism. It is something comparable to the river discharge. But in order to find out the tidal prism, we have to have a detailed tidal record for the entire period. And then we can see how the tide is, rising and falling. Now you can see these two curves. One is from Shagor, that is the mouth of the Hooghly estuary, and this is 2,209 kilometers upstream from Shagor along the Hooghly. Now you see that near the mouth at Shagor, the rising limb and the falling limb, they are almost similar. So you have almost equal duration of flood cycle and ebb cycle. But when you are going inland, the falling limb, as you can see here, is much more gentle, and the rising limb is very, very steep. So it means that the flood tide is rising very fast, but the ebb tide is receding at a very slow rate. So this has a very profound impact on the sedimentation pattern of the coast. So this is a visual tidal scale. You can actually see how much water is increasing, and you can record it. So that is a visual scale. There are automatic tide gauges also, but we do it visually, manually. It is easier and within our scope. So you find out, as I showed you, the different stations which are located, the bay I showed you. So some of the locations are near the coast, some are inside the bay. And the tidal ranges are different. The duration of flood tide and ebb tide are different. Though it is not a major difference like I showed you in the case of Hooghly, because these are small tidal channels, but still there is a certain amount of change. So the observations we can have is, what is the velocity of tide which is getting in the bay, and what is the velocity of the tide going out of the bay. So these are some of the conclusions that you can draw from tidal measurements. Now coming to another important part of coastal research, and that is material analysis. As you know that sediments, they are extremely important, and they actually tell us that how it has come, how it was transported, what was the medium of transport, where it is coming from. So it can give us a number of informations. So here also we try to collect sediment from various locations, and we wanted to know that how the sediments came here in the bay. It is coming from the seaside or the land side. What is the character of the sediment? It is coarse or fine. So all these things are actually giving us information about the depositing environment, the environment in which the sediment was deposited. It was a high energy, low energy, tidal, wave, what kind of energy was responsible for the deposition. So suspended sediment, all of you know, that is one of the very easy ways of finding out. So you just collect samples. You can take it from various depth by bottles like this. These are called siphon bottles. You can put it inside the water and then you collect the sample. You just place a filter paper like in the shape of a cone and pour the water through the filter paper, and simply the suspended material will get stuck in the filter paper. So what I have shown here is a filter paper which has been dried, and I just took a photograph of that just to give you an impression. This is a high tide sample and this is a low tide sample. So you can see that much more material stuck into the filter paper during high tide. So it means that when the water is getting in, it is carrying a lot of sediment. While it is going out, it is carrying out lesser sediment. Now this has an implication, which means that maybe a part of the sediment is trapped inside the bay. That is why the outgoing tide is carrying out very little sediment. So this is a very simple way of finding out. The quantification of the bed load is relatively difficult because here you have to collect the sample from the bed of the area. So either you have to get hold of a boat or a ship, and then you have to immerse these grabs inside the water, and then you can take out the bed sample. So in an open coast, in an ocean, in a sea, it is difficult. So using grabs in the coastal area is difficult. You have to have a specialized vessel for that. Otherwise, we cannot use these grabs. Now, as this is a very important method of finding out from where the material is coming, and that is called heavy mineral analysis. As I told you that geomorphology is an interdisciplinary subject and it has a major role of geology in it. So what we are actually trying to find out is that what are the minerals found in the sediment, and if these sediments, this group of minerals can tell us something about the place from which they are coming. So these are the common minerals that I found in my area. And these has been seen under the microscope and then we identified. But the interesting thing is that many of these areas, these minerals, they are coming from some basic igneous rock. And as I told you that the area which I am talking about is a part of the Maharashtra coast, Konkan coast of Maharashtra. So you know that is a Deccan lava province. So you have basic rock everywhere. In the catchment of the bay, in the wave-cut platform, everywhere. In the headlands. So everywhere you have basalt. So it is nothing unusual that you have minerals coming from basic igneous rock. But it is interesting that you have some minerals like kyanite, which is coming from metamorphic rock. So when you find out that, then we have to think that where did this come from? And you try to look for areas which have metamorphic rock nearby. And when you locate such an area in the coastal area where you have metamorphic, then you can say that, okay, this material is being transported to such and such location, then it means that there is a source of sediment from offshore, which is coming from the seaside. It cannot come from the land side. So such interpretations we can do. We can map them. We can show which parts are having which type of mineral. Of course, you cannot have one mineral only. There should be a group of minerals, a mixture of minerals, and from that we find out that what is the probable source of the rock, and which is in geology termed as provenance. Another very important contribution of geology in this kind of research is we are very interested in finding out old sea level signatures. Now we are always talking about sea level change. And mostly they are related to the phenomena called climate change. So what we have in our mind is everywhere the sea is rising, so everything is getting drowned. But it is not so everywhere. And this is a very important understanding. You cannot generalize some things. You cannot generalize fluctuations of sea level, because sea level is a very, very complex phenomenon. And it includes not only the rise of the water, but also the tectonics of the land, also the phenomena of glacial unloading. So there are other factors which should be kept in mind when we are thinking about sea level. In this area where I worked, here we found some very interesting depositional features which actually resemble the beaches that we see, but they are all hard. They are sand but turned into rock. So beach sediment turned into rock. And how they were turned into rock? That is because the beaches, as you know, they contain lot of shell material, carbonate material. And these carbonates, they precipitate, act as cementing material, and that causes the beach sand to become hard and turned into rock. And these are now found sometimes 500 meters, sometimes even 1 kilometer from the present shoreline. So they tell us about the past beaches when the sea level was higher, and those areas where the then beaches, spits, dunes, etc. Now they have turned into rock, but now the sea is some 1 kilometer or so far from these areas. So these are definite signatures of sea level fall. This is how we study the beach rocks under the microscope. You can find out various microorganisms, and these organisms, they tell us about the environment in which the beach was formed. you all learn about something about the ecology, something about the ecosystem of ponds, of forests, of deserts. So these are beach environment or lagoonal environment, and a typical type of foraminifera occur in those areas. So when you look into the microscope, you see the various forms of the bivalves, the foraminiferas. So you can interpret that what kind of environment it was when the rock was deposited. And this is also a direct application of geological methods in geomorphology. This is how the inference is drawn. And this is a very small yet important study which we do now, that is micro level study. You see, most of the landforms that we monitor, that we see, take a long time to actually form. But these are microforms and they change every minute. So if you stand on the beach and you monitor these features, you can actually know about the wave process, the current process, what is the changing velocity pattern. You can also check for the bioturbation marks. These are the marks which are left on the beach by small crabs or insects, worms. So you can study those. And these are a very upcoming field of biogeomorphology. So you can study such forms also. And they also give us important indicators regarding the beach submergence, the amount of energy which is present on the beach, the type of material, everything. Now, going very briefly into the other side of the coast, and we just experienced 2 super cyclones in 2 consecutive years, Amphan and Yas. So management of coastal erosion is also a major part of coastal geomorphology. And we have seen that they have done extensive damages, though the landfall was in Odisha, but the entire Medinipur coast and Shagor has been devastated and a large part has been damaged. So that is why I will talk briefly about coastal management. These storms and these events that we faced have posed very pertinent questions. We have seen that they actually show that we are not prepared to face these storms. We take precautions. We took precautions this time, at least, by cutting trees, putting down some of the hoardings. But we have already done some damage in the coastal area, which we cannot undo. And so, such storms will go on having a very, very severe impact on our coasts. We have managed not understanding the system properly. We have only kept one dimension of the problem in our mind, and that is there is erosion. We must stop erosion. We must also understand that erosion and deposition are two inseparable processes of any natural system. So if you forcibly try to stop something, there will be repercussions. And we must keep that in mind. We have also seen that there has been blatant violations of the CRZ rules. And today, the areas which have been damaged, say for example, areas like Digha or Tajpur, the hotels which have come up just on the highest high tide line should not have been there at all. So permissions were given, the hotels were built, markets were built, shops were built, and now when the storm devastated everything, then we question ourselves. So we have to learn and not repeat the mistakes which we go on doing. So basically, the thing which has to be kept in mind when we are managing a coastal area is that we have to maintain the sediment budget. Means that it is very natural for the beach to get sediment and lose sediment because the waves are coming and going. The longshore drift is going and coming. So they will bring material, will take out material. It is a natural process. But we also have another thing, that is the dune, which is backing the beach. And the dune supplies sand to the beach. When the waves are hitting the base of the dune sand is collapsing, it is falling on the beach, then it is distributed by the swash backwash over the beach surface. The dunes also shift backward when they are threatened by erosion. I will show you a little later. So these are very natural phenomena. So the input and output of sediment, that has to be kept in mind. And in sandy beaches, we have flat wide beach in New Digha. We have areas where there are lots of crab holes. These are the mounds made by red crabs. The dunes are here, high dunes. This is the area which is after the Hotel Seahawk, going towards Digha Mohona, this area. The dunes were protected by bamboo and eucalyptus tree trunks, but that was in 2011. Now that has been concretized by another wall. So you have huge dunes. There are vegetation on the dune. The New Digha dunes are a bit lower. They also have vegetation on them. So these are very natural beach dune systems, what we have seen in the past. The tidal flats, they have a different ecosystem. There are different type of crabs called fiddler crabs. You have the mangroves. You have the mangrove associate plants. And they have a different type of ecology. So a sandy ecology and a muddy substrate ecology is different. We have to maintain both. Now, very common engineering structures that we see, that is the seawall. New Digha, we had laterite bound seawalls. In Old Digha, we have concrete seawalls. Another important engineering structure is the groin, and that is not parallel but perpendicular to the beach. This is found in the Old Digha, in the Digha Mohana, that is between the end of Old Digha and the Digha Mohana. This is the portion Gangadharpur, and this is on the left you have the Digha Mohana, that is the Champa estuary, and the right hand side is towards Old Digha. The seawall has it was built long time back during the 80s. It was damaged, then rebuilt again by concrete. The problem with concrete is that there is no scope of dissipation of wave energy. So the wave that is hitting the wall has no scope of percolating because it is entirely lined up by concrete, which was not there in the case of the laterite wall. But then again, laterite couldn't sustain the impact of the storm. So we had a very big storm during the 90s, and then this wall collapsed, and then it was permanently lined up with concrete. The major defect was that the wall was constructed only up to the last big hotel, that is Seahawk. After that, it was just left like that. So abruptly, the wall ended. What happened was, just after the wall, this area was severely eroded. We tried to protect that area. This is the area after Hotel Seahawk. And we tried to protect it time and again by putting boulders, by putting bamboo stakes, but it didn't help. But this was inevitable because this is sheer mismanagement. When you know that this area is eroding and you leave a wall halfway through, then this is bound to happen, and it happened. Now, the problem of a concrete wall is, as I told you, that the waves cannot dissipate their energy. And as a result, what happened is the backwash was extremely powerful, and it took away all the beach sand. So here are two profiles. One profile is of New Digha, another profile of Old Digha. And now you can see that the beach is only left this much. Now this year, when this overtopping happened in Digha, then there was a large hue and cry that why this happened, and this is the wall has not been properly built, the stones have not been properly put. But the major factor is that a concrete wall in such an eroding environment should not have been constructed at all. So the beach is totally absent, and the beach acts as a dissipator of wave energy. So when you don't have the beach, there is nobody to dissipate the energy. And that is what is happening. There is toe erosion just below the wall. They are, putting sandbags just below the wall, but it's not helping. Again and again, this area is getting eroded. It is just at the base of the concrete wall. Now, why did we do such a blunder of building a concrete wall here? This is a wave refraction diagram of this area. I already told you what the refraction diagram tells us. And you can see that this area, this is the Digha area, this is the wall. So this map was prepared long back in 1970s, much before the wall was constructed, and it shows that there is a definite trend of converging waves, and this area is prone to erosion. So in such a circumstance, which we actually should not have left the wall incomplete, suddenly terminating after the Hotel Seahawk. And it resulted in severe dune erosion. You see this building which was behind the dune? The whole dune was eroded. This was in 1999. In 2005, this whole thing is gone. The house is abandoned and it's all eroded. Now we have a conventional idea in mind that you have to plant trees when you have erosion. There also, we have to keep in mind, not always, because the dunes in an eroding coast have a tendency to migrate backward, free migration. When the wave is hitting from one side, they migrate backward. When you plant big trees on such dunes, on eroding coast, the roots go deep inside and they fix the dunes. They don't allow them to migrate, like you see in these pictures. They are big trees, casuarina, eucalyptus, all these trees, they are big trees with deep roots. So it doesn't help. And see this dune. I took this picture in 2012. And this dune has migrated freely. You see it is white sand, nothing on top, no vegetation. It has migrated onto the agricultural field beyond the dune. So dunes should be allowed to migrate, otherwise they will perish. And we should not plant big trees on dunes in eroding coast. This is what happened in case of Yas, in case of Amphan. You see this is the same area. You can identify the umbrella here, that this tree is this one, this is this one. Number of overtoppings we had, 94, 2000, 2001, and every time the wave is coming on to the pavement above the wall. Why did this happen? Because this is occurring in Old Digha. Because in Old Digha, as you saw, we have sacrificed the beach. We built the wall, we stabilized the dune behind that, we built the concrete wall, and there is no beach to dissipate the wave energy. So the entire water is coming up and overtopping the wall. So this is something which we ourselves did. Now, if we say that, why did this area is damaged? It was such a huge storm that everything is damaged. Yes, it was but we also crippled the natural recovery system without understanding that how the system works. The groin actually is better. They intercept the longshore drift. It is perpendicular to the coast. And as you can see, these are concrete blocks, but they are like, they have legs, 3 legs. So if you just dump them, there is lots of space in between. So when the water is coming, hitting, it percolates through these gaps. And you can actually spare major erosion. So one side you have deposition. Say if in this case the drift is coming from the right to left, this is the river, so drift is coming from the other side, so it will deposit on the beach and the mouth of the creek will remain open. So that has happened. You can see this profile. This side, the low side, that is on the river side, it is low, and the beach, it has gained elevation. You can see the mud here, it is getting elevated. So we have to keep in mind that when we are actually building a wall, we have to understand that we are counteracting a very, very powerful process as the sea wave. We have to also pick the material very carefully with which we are building the wall. It should not be like laterite, it's just collapsing with one wave impact. And again, it should not be like concrete, which is reflecting the wave 100%. There is no way of percolation of water. We have to maintain the sediment budget. When you are building a wall, you are cutting off the dune and the beach. As I told you, that the beach, when it loses sediment, the dune gives it sediment. So when in Old Digha, you have built the wall, you have stopped the dune from contributing sediment to the beach. And the beach is being continuously eroded. So the sediment budget is negative there. And that is why the dune is, totally out of bounds. It is concretized. It is built up. You have flattened the top. You have built hotels. You have built shops. And after doing so much of damage, we expect that nature will follow our way of management. That is where we have to be conscious. We are dealing with severe storms. So if we do not manage the coasts properly, time and again, we will face this problem. In Shagor, there was no erosion in the middle part of Shagor for a long time. Yes, there was when the Kopil Muni Ashram had to be shifted, but mostly the erosion was concentrated on the southwestern and southeastern corners of the island. But now, in front of the Kopil Muni Ashram, there has been massive concrete structures, Natmundi, Dhalai Arcade, where shops have come up, all concrete, the dunes have been flattened, and now, in this storm, yes, it has shown us what blunders we are doing. So, I will end my talk here.
Thank you, madam, for that very insightful and informative talk. We have a number of questions, but before we get to the question answer session, I request our principal madam, Dr. Shukla Hajra, to kindly make some observations and thoughts. Madam?
Yes, it is a very good lectures. Not only I'll mention that the Professor Shubhamita Choudhury, she's a professor of Department of Geography, West Bengal State University, and she delivered a so good lecture, which will be very useful for the students. How to work on that. First, the processes. She mentioned about the processes in detail of the coastal research work on coastal geomorphology on the two parts. She mentioned on the western coast hard work, research work, and how did she do in this work. And the next part is the Digha coast, what are the damages going on, what are the causes, what are the responsibility, what are the wrong decisions, and the continuous monitoring she did. She is not Professor Chaudhary. She is doing a continuous monitoring. Not that she stopped it. It is a good lesson for the students. When you start with a problem, when you start to work with a problem, and you must do it for a long time. What is going on? And she mentioned the coast of Digha, the hotels, what are the causes of the damages, and the sand dunes, which is actually damaged by the construction, and also the measurement, how you can measure the sedimentation on different processes. So one side she mentioned the processes, other side she mentioned the effect. And students, I think research students and other students, UG/PG, they are highly benefited with her lecture. I thank you, Shubhamita. I heartily thank you for your lectures which you delivered today evening to our students and all participants. Thank you.
Okay, madam. So Rajarshi, do you have questions or we end here?
Rajushi, you are muted. Rajushi.
Yes, madam. We have plenty of questions, madam. So should we start that, or can I just make a brief summary of your talk?
No, you see the questions. Some of them may be some common questions also.
Okay.
So you can pick some questions which are interesting or more relevant.
Okay. So, madam, there's one question that is asking us that processes are essentially continuous or episodic actions that require constant monitoring, whereas patterns are assemblies of forms that are associated with particular processes. Given the available resources, is it possible by our scholars and students to actually monitor the processes? And secondly, is it possible to discern the process from the form? That's one question, ma'am. And then from the same person, madam, in case of a subsiding or uplifting coast, how is tidal gauging corrected in conventional star feeding method?
One more question is there.
Okay. So the first question, though a bit long, but what I understand is that he or she, I don't know, but is asking about how we can, monitor both process and form, and if it is possible for a scholar to monitor processes. Well, I actually talked about resources by which you can monitor, and whatever I presented today, it's my first-hand experience. So it is not that I am telling something theoretically. What I have done, I have told. So it is possible to monitor with limited resources. Yes, you have to find a way. You have to find the most suitable method that you can do by going through a lot of literatures which are coming up, and you try to see that similar type of research is being done with what type of methodology. some of the methods you will find that you cannot apply for various reasons, but some of the methods you can apply. And then you may have to modify it a bit. Such modifications also must be scientifically done. You have to discuss with your supervisor how such modification can be done so that the method can be applied in your area with your available resource. But of course, it is doable. The second question, what was the second one?
Madam, in case of a subsiding or uplifting coast, how is tidal getting corrected in staff feeding method?
See, here is a basic confusion about the rates of change. You are monitoring in a day. The upliftment and subsidence takes centuries. So they are processes which are very long-term processes. And you are monitoring now. So whatever datum is there. One thing I haven't mentioned, but actually it was a long lecture. So in case of tidal monitoring, we actually adjust all height of water level from a datum which is called a chart datum. And that chart datum is specified by the relevant authority. In the sounding charts, it is mentioned that what is the chart datum, where is the benchmark, and the chart datum is at what depth. Now, what is a chart datum? Chart datum is an imaginary datum which is below the lowest low water level. And that is why the tidal data is always positive. No tidal data is in negative value because the chart datum is considered as the zero, and that is somewhere below the lowest low tide level. So if the lowest low tide level is say 0.9, it means that the chart datum which is below that is 0, and above that the water is 0.9 meters high. So the sounding charts tell you the chart datum is at what depth. Usually some nearby port where the benchmark, Survey of India benchmarks are there, or sometimes PWD benchmarks are there. So it is mentioned in the sounding chart that the chart datum is so many meters below the benchmark which is situated at such and such location. So where I am doing the tide monitoring, if it is not near the benchmark, then the first thing that we have to do is we have to do a leveling survey from the given benchmark to the area in which I am doing my tide monitoring. And there we set up a position which is accessible, and we set up a benchmark there related with the benchmark which is mentioned in the map. Like that, we adjust the tidal measurements with the chart datum. And that is done for all the tidal records which are being published. So we are also adjusting it with the chart datum. So the subsidence or upheaval that happens in a very long period of time. When that happens, then the benchmarks also will change.
Thank you, madam. There's a follow-up question that says, how much is the difference between the Everest and the WGS 84 datum for a distance of 1 kilometer in our area?
I already showed you that two comparable figures. I can show you again. So those are in meters, so you can just see the difference. Can I send the PPT to you and you later show it, because it will take a bit, long time to answer all questions.
Okay, madam. So
I can show this one. I'll just show. Is it visible?
yes, madam.
Okay, so the table is here. So you can see the two axes, how much is the difference. So you can just subtract them and find out. These are in meters. So you can easily convert it in kilometer and see that how much is the difference. You will subtract one from the another and you will find out, you can see how much is the difference in x-axis and y-axis.
Okay, madam. And our third question is from someone else. Can beach rocks be considered as signatures of tsunami deposits?
Yes, sometimes old records of tsunami can be there. So they will have definite different type of sedimentary structures in them. High energy wave action. So they have different signatures altogether. So if there has been a tsunami you see, these beach rocks are not very old. They are formed between, say, 3 to 6,000 years in the Indian coast, I'm telling. And beach rocks you will find in India mostly along the peninsula coast, in southern peninsula, Tamil Nadu, and some in Maharashtra, and also some in Gujarat. You don't find beach rocks in the eastern coast, say Orissa onwards. There is no beach rock. There is only unconsolidated sand. And that is not because sea level never changed here, because you can find very definite signatures of successive chainier ridges in Subarnarekha mouth. Those are well researched, but they are not consolidated into rocks. They are still in the form of loose sand. They have not been lithified. And that is mostly because, though such study has not been done yet, but it is my inference that the amount of carbonate present in the sand is very low in case of the eastern coast. So here the beach sand, the dune, the old dunes, which are of similar age as that of the beach rocks in the western coast or Tamil Nadu coast, but they don't get lithified. because for lithification you need carbonates. And here, because of large rivers, they are bringing mostly siliciclastic material. So carbonate sand is less and silica-rich sand is more. In the west coast or in the southern Tamil Nadu area, there you have carbonate-rich sand. So that is why the beach rocks are forming there.
Madam, in case of a cyclonic landform at the northern Bay of Bengal, how is wave refraction taking place? Does it have any relationship with the breaking of the embankments in a particular part of the coast? Are rip currents anyway responsible for that? Somewhat linked questions here.
See, rip currents are related with various factors like beach slope, the angle of wave approach, and they are very well related with diffraction and longshore drift. So, origin of coastal cells actually tells us about the areas of erosion and deposition, but relating them with cyclonic storms is difficult. The coastal cells, the erosion process goes on operating in an area even without cyclone. During cyclone, all the wave parameters change. The wave heights are excessively high. So the amount of refraction, the amount of wave energy, breaking wave energy, everything is changed in a very small span of time. So, in order to study the impact of all these parameters during a storm, we have to have proper wave climate data during the storm period. Then only we can relate it properly with the erosion process. So if there is available data of the storms during the storms, it is difficult to get a data because, majority of the data, both the tide data and the wave predictive data, that is, in most cases, in the beginning of the year, you can get the prediction of the entire year. But in between, especially for the tide, for waves, the generation of the data, the data is given not for the near shore area, but what I showed you, the wave climate data, these are all deep sea data. What we do is, we try to calculate how the deep sea waves will transform when they are approaching the coast. So when the storm is coming in the deep sea, then we have to get the data. And for that, we have to calculate how it will transform when it reaches the coast.
Okay, madam. Does anyone else have any question for Shubhata, madam? Anyone of our students have any question? We have several of our special paper postgraduate students here. Okay, so if not, Madam, thank you. We have learned a great deal from this lecture about various kinds of processes, the ways to measure them, importance of sediment analysis, tidal measurements, and what has gone wrong with coastal management in our part of the world, particularly. Thank you very much, ma'am. So before we end, it is over to our HOD, Madam, Dr. Panchani Majumdar, who will take over now. Madam?
Yes, Rajoshi. Thank you, Shubhamita. Thanks a lot for delivering such a nice lecture. As far as I know, that Dr. Shubhamita Chaudhary is not only a person of academic excellence, but she is an avid researcher to see the application and outcome of the innovative pursuits. So I'd like to thank her a lot because when she was delivering her lecture, I memorized the days in my childhood. A very favorite place of my family, it was the Digha area, where we usually played the game hide and seek in the within the cashew forest and casuarina trees. And nowadays, when we went there with our students before this pandemic, we have seen the concrete beaches, and that was a very much. We were very sad to see all these things. I remember the days with Professor Manotosh Kumar Bandyopadhyay and Professor Shunando Bandyopadhyay in Shagor Islands, and that was we went to Topobon, and that was a very nice place. And the whole coast, we traveled by walking with our professors. But nowadays, when we are going there, we can see the concrete beaches that are very much hampering our ecosystem, and that we can see in the wind. In the last year, we have seen the effects of Amphan. And as I have just mentioned, that Professor Chaudhary is not only a person of academic excellence, she was with the people in the wetland. Today, we are talking about to restore, to reimagine, and to recreate our ecosystem. And if we only confine ourselves within all these webinars, this is not the proper way. The way she has so shown us in the last year, not only taking initiative by her own, but also taking the students of West Bengal State University so that they can also be a part of these work that she has done for the Amphan affected wetland area people. They have done a lot. We are very proud that our West Bengal State University students were with that Amphan affected people in the wetland area. And I would like to mention her name in a special way because she was the person who took the initiative to introduce QGIS, quantitative GIS, QGIS in West Bengal State University, because QGIS was an open software. So by using this open software, the students, even in the as West Bengal State University deals with the students who are usually residing in rural areas. So the students, even at the remotest corner, can access the software very easily because it's a free software, not a vendor one. So thanks to Professor Chaudhary for delivering such a nice lecture in such an important day, Environment Day, when the whole world is facing this pandemic situation, and we, the academicians, everyone, we are facing this situation in a very problematic way. We are facing this situation. We have lost our friends, our family members, but still, we never make a full stop. We have to do many things for our future generation. And I hope that our students,
they will render their selfless service to the society so that the future of our earth, our mother earth, should be protected. In this regard, before I formally give my vote of thanks to all the speakers, particularly our student speakers, our respected principal madam, on behalf of IQAC, I think the academicians can change a lot the world with the help of our students. And in this regard, the NSS volunteers, National Service Scheme volunteers, have a very important role to play with. The students, on behalf of IQAC, I must say that the students are the main stakeholders of our institutions, our higher education institutions. And so we started our day with our students, and we will end our day with our students. Now I would request Pooja Pal, our NSS volunteer and our student, to say a few words in this regard, in the World Environment Day. Thank you. Over to Pooja. Pooja, can you hear me? Hello, Pooja.
Yes, ma'am. Hello, ma'am. Yes, ma'am. Thank you, ma'am. উপস্থিত সকল শিক্ষক শিক্ষিকাকে ধন্যবাদ জানাই, নমস্কার। আজকে আমরা এই বিশ্ব পরিবেশ দিবসে এখানে মিলিত হয়েছি। আমি একজন এনএসএস এর সক্রিয় ভলেন্টিয়ার। আমরা বিশ্ব পরিবেশ দিবস নিয়ে অনেক রকম র্যালি করেছি কলেজেরই আশপাশে এলাকায়। মানুষকে সচেতন করে এসেছি যে কিভাবে গাছ লাগালে বা বৃক্ষরোপণ করলে খরা বন্যার হাত থেকে রক্ষা পাওয়া যায়, তেমনি উপড়ে না ফেলতে যত্রতত্র গাছের, সেই ব্যাপারেও মানুষকে সচেতন করে এসেছি। এছাড়াও গাছ কমে যাচ্ছে যে দিনকে দিন, তার সাধারণ পরিস্থিতি আমরা এখনই দেখতে পাচ্ছি, আমাদের সামনে ফুটে উঠেছে। তাই সকলকে অনুরোধ, গাছ লাগাবেন, বৃক্ষরোপণ করবেন, করে নিজেও সুস্থ থাকবেন এবং পরিবেশকেও সুস্থ করবেন। ধন্যবাদ। কোনো ভুল ত্রুটি হলে ক্ষমা করবেন। নমস্কার।
Now this is the time for formal vote of thanks. Before going to give my formal vote of thanks, I would like to mention, I think here Professor Ellen Shatpathy is present here, and I would like to give him a big thank you, sir, for presenting, for your presence here. Thank you so much, sir.
Yes, Didi.
Would you like to say one or two words?
Yes, I was listening to Madam Chaudhary, and I was wondering that out of so much of passion and dedication to research, what she has accomplished. This was not a single lecture. Actually, at least 4 to 5 lectures she has covered. And with commitments, it is not just like the academicians usually do. So it's a wonderful learning experience for all of us, for all the scholars, all students, that how she did it with the least available resources in those days, during her PhD days especially. And many of her works she has shown here. Really, hats off to Madam. Thank you very much. I have nothing more to say. And one more thing I would like to add, or if you want to comment, regarding the beach nourishment exercise that was initiated by Yogi and others through Subarnarekha sediment supply. But is there any connection with the Subarnarekha barrage and all that? And there is another issue. I know that you are visibly tired, but still I am disturbing you. And secondly, the presence of the paleo-dunes in Digha area, these are much inside in the inland areas. Don't you think that these are some of the evidences of the sea, that the sea may come to this place as well? So there should be a buffer of at least 1 kilometer where no construction should be given. So, madam, your comments.
Yes, Loki, this has already been, extensively researched by Parthasarathi sir also. So these dunes, the paleo dunes of Digha, the last row, that was formed around, more than 3,000 years back. So when we are thinking about the CRZ, we are restricting the area just 500 meters from the highest high tide line. But we are taking that in terms because of the present sea level, present highest high tide line. So if you have to consider the last dune, so the area covered up to, it's about more than 4 kilometers. That is difficult because all the area, in front of that has already been built up long back before the CRZ rule even came into place. The present rule, whatever is there, if that is at least, we are compliant to that, that also will save a lot of resources. Leaving aside 4 kilometers, at least 500 meters, that also we are not compliant. So, and all the big hotels in Mondarmoni, everywhere, they are actually standing on the highest high tide line. And what I was telling the students also who initiated today's talk, they were telling about environmental consciousness among students. So this I also tell my students that when they go to these beach resorts with their family, they also look for rooms which are, having a direct view of the sea and the waves are coming onto the window, and people are very happy actually. They want that type of room.
No, that means instead of investing so many thousands of crores of rupees for embankment concretization, selective resettlement to inside areas and evacuation, I think that will be better option in the long run.
Yes, absolutely. And it is not required to concretize everything. Some places, at one place we are talking about ecotourism, and in another area when we are constructing huge concrete structures, then it is jeopardizing the entire situation. So let us leave a little space for nature.
Yes, breathing space for the nature. Thank you very much.
Okay.
Okay, Panchali, thank you for allowing me. Thank you.
Thank you so much.
Okay, thank you, Panchalidi, and thank you, madam, for giving me this opportunity to talk on this special day. I am also happy to interact with students and scholars, whoever were there. So I think let's call it a day. Good night to everyone. Stay safe. Okay. Bye.
Thank you, madam.
So at the end of the day, I want to sum up. Many thanks to our respected principal madam, without whose encouragement and initiative we can't proceed a little bit also. Actually, during this mental trauma period, madam helped me a lot, and Professor Shubhamita Chaudhary, Professor Lakshminarayan Shatpathy, and everyone. They helped me a lot to overcome the situation. And I think with the help of our students and like me, everyone can overcome the situation. Every one of us, when we can see our WhatsApp group, we can see that many students are often writing this, that madam, all my family members are COVID affected except me, so please consider me for today's class. And we are facing all these sort of problems each and every day. And during this period, it's very high time to say these words that I সবে বেঁধে বেঁধে থাকি। আমরা যদি একসাথে থাকতে পারি সেটাই আমাদের সবচেয়ে বড় কথা। Our principal madam always encouraged us, and this Environment Day, on behalf of IQAC, I would like to thank all the members of this Calcutta Girls College, all the faculty members, all the non-teaching staffs who have took every initiative to run the process in a smooth manner so that the higher education never make a full stop during this pandemic period. I would also like to thank our beloved students who are the main stakeholders, আর আমরা যাকে বলি বাংলায় প্রাণ ভোমরা আমাদের প্রতিষ্ঠানে। So without them, all the things are meaningless. And I think Professor Shubhamita Chaudhuri, within this special lecture, has delivered so nicely to research scholars, to faculty members, and to our postgraduate students. Even our UG students, some of our UG students are also here. I think some part they may not understand, but in near future, when they will pursue their higher education, they must remember this lecture as a very valuable lecture for their whole journey. As when we were students, we often used to go to field with our professors, but sometimes we never understand at that time what is the meaning of doing this thing or that. We were asking questions to sirs, but sometimes it was beyond our capacity. But nowadays, when we are recollecting all that things, we can understand that what we had with us. আমরা কাকে পেয়েছিলাম, কাদের সঙ্গে আমরা যেতে পেরেছিলাম, কি দেখতে পেরেছিলাম, কি বুঝতে পেরেছিলাম। This is very important for today. And with this aim and objective, the Department of Geography, East Calcutta Girls College, along with its all faculty members and all the students of the department, and also the research scholars, we are the department with our postgraduate study, and our research scholars are there doing their research under Dr. Shukla Hajra Madam, our principal is Calcutta Girls College. And so they have also give every support to us, our faculty members, Dr. Annesha Haldar, Professor Rajushi Rajgupta, Dr. Pinaki Sarkar, Professor Shubhasri Singharai. All of them have extended their help, and all the faculty members of East Calcutta Girls College, particularly the faculty members who are engaged in the Eco Club of East Calcutta Girls College, they have extended a lot to organize this Environment Day. And thanks to Department of Geography, all the laboratory staffs, all the non-teaching staffs who are doing everything for us. They are not here, but they are doing everything for us. So thanks to all of you. Good night to all of you. Thank you so much. Madam? Hello, madam. Rajushi?
Yes, madam.
একটু madam কে বলো যে
Yeah, like, principal madam, should we end this now?
Madam is muted.
Yeah, she's here, but